Okay, so this video is meant for my geometry students. We have a test coming up on Friday, and this review is to help you prepare for that test. This is the second half of the chapter. Make sure you review the first half as well. So we're looking at sections 4.5 through 4.7. So section 4.5 was on isosceles triangles and equilateral triangles. So let's take a look at these two problems here. Okay, we have to find x and y. So if I look at these two problems, all right, this is, let's say, problem set 1. Okay. In this problem right here, I have two isosceles triangles. Okay? So you can almost split them in half. You could treat this one as its own with x in it, and this one as its own with y. So let's look at the red one first with x. And I'll say, okay, isosceles triangle, I have two sides congruent. By the isosceles triangle theorem, I know that this angle right here is congruent to that angle right there. So if this is 50 degrees, so is this angle up here, 50 degrees. So now in this triangle, I have three angles, x, 50, and 50. I can solve for x by using the triangle angle sum theorem. So this isosceles triangle theorem gives me the two congruent angles. And then the triangle angle sum theorem says they add to 180, the three angles. So we have x plus 50 equals 180. And we have x plus 100 equals 180. Subtract 100 from both sides. And x is 80. So now in the other triangle we can do the same idea, okay? So we have the isosceles triangle theorem. I'm going to work down. Isosceles triangle theorem that says if these two sides are congruent, then these two angles are congruent. So if this is a y, then so is that. That's a y. And now I have the three angles, y, y, and 100, and I can add them and set them equal to 180. So again, we use the isosceles triangle theorem. Sorry about the color. We use the isosceles triangle theorem to get these two angles congruent for the congruent angles. And then we use the triangle angle sum theorem again for the 180 degrees. So the equation for the triangle with y, let me scroll down, is y plus 100 equals 180. That is 2y plus 100 equals 180. Two steps now. Subtract 100 from both sides. 2y equals 80. And then divide by 2. And y is 40. And there's the value of x and y in this picture. Okay? Alright, so let me draw a little divider here, and I'll slide over. Okay, so what about this picture over here? Well, first thing is, I have an exterior angle. Okay, so how do I handle that? Well, I have an exterior angle, but I also have an isosceles triangle. So let's go back to that isosceles triangle theorem. That says if I have two congruent sides, those legs, then the angles opposite this end and that one are congruent. So if this is y, so is that. Now how is that going to help me? Well, look at this connection right here. We have a linear pair now. And linear pairs are supplementary. So I know that y plus 110 equals 180. I'll subtract 110 from both sides, and I know that y is 70. Then I will take the y is 70, and now I have two of the three angles in this triangle because I have y is 70, and now I need x. So now I use the triangle angle sum theorem. And this is going to say that 70 plus 70 plus x is 180. Let me scroll down. So 70 and 70 is 140. Subtract 140 from both sides. X is 40. And there are the value of x and y in this picture. Okay, so a lot of isosceles triangle theorem, a lot of triangle angle sum theorem. This is not going to be a separate problem, but I just want to recall the idea of an equilateral triangle while you're here. So if you have an equilateral triangle, which means that the three sides are marked congruent, this also means you have an equiangular triangle, which means that the three angles are congruent, which means each of those angles is 60 degrees. So remember that idea. That's that theorem 4.5 from, or no, I'm sorry, not theorem 4.5. This is the corollary to 4. This is that corollary that we talked about. That's a note card. Okay, so remember this idea. Okay, so next we're going to complete this proof together. So I need my statements and my reasons. I have this picture here in the given segment LO bisects angle MLN, and I have some perpendiculars. Segment OM is perpendicular to segment LM. Segment ON is perpendicular to segment LN. And that's all given to me. So in my picture, I should mark this information. LO bisects angle MLN. So find angle MLN. It's this angle right here. Bisect it. Split it into two. That's going to be an important part of this proof. Second, perpendicular. OM and LM are perpendicular. There's one right angle box. ON and LN are perpendicular. There's another. You have right angles. So if we're trying to prove these triangles congruent, we have, so in my thoughts, we have four ways, right? We have side, 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 angle, side, angle, side, angle, and angle, angle, side. But now that we have right triangles, we should also look at that HL congruence. So let's see what we can do here, if we can make that happen. Because notice, what do they give me? They give me an angle pair, and the right triangles. Okay, so let's see what happens. Well, notice that HL involves two sides. Right now, I have information about two angles. So we are not going to use HL in this proof. We're not going to use side, 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 or side, angle, side in this proof because we have two angles. We need to find information elsewhere. Okay? So I hope you can see how, even though you have right angles, you might not use HL. This is a very good proof to practice. Okay? So what are we going to do then? Well, I'm going to say that these two angles are congruent. Angle MLO is congruent to angle, so MLO, MLO, NLO. And that is because of an angle bisector. Definition of an angle bisector. So there's a pair of angles. Now, we know that these two are perpendicular segments, so we know that these two angles are right angles. We can name it with one letter, that's fine. Angle M and angle N are right angles. That is because of definition of perpendicular lines. Then if those right angles are right angles, then we know that angle M is congruent to angle N because all right angles are congruent. And there's another pair of angles, A. So now I need the side, either the side between or the side not between. And if I look at these two triangles, they share OL. So my fifth step, OL is congruent to itself. That is by reflexive property. So then finally I have my side. This side is not in between the angles, so it is angle, angle, side. Triangle LMO is congruent to triangle LNO by angle, angle, side. So a very good proof, despite having perpendiculars or right angles, it's still not HL, it's some other way to prove triangle is congruent. This is a very good example. Okay, let's try another proof here. So again, statements and reasons. This is still, it's a pretty proof-heavy test, okay? So in this picture here, we are given a couple things. Number one, segment HV is perpendicular to segment GT. Segment GH is congruent to segment TV. And I is midpoint of HV. That's all given to me. Okay? In my thoughts, I am trying to prove triangles congruent. So remember, we have many ways to do that. Side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side. And then I see this perpendicular. So I think maybe HL as well. Okay? So let's try to map this out. HV and GT are perpendicular. So this creates these two right angles. Both of them are right angles, okay? There's actually 4 right angles, but the 2 that matter are the ones in the triangle. GH is congruent to VT or TV, okay? There's a pair of sides. And now if I is the midpoint of HV, I is here, splits HV into 2 equal parts. And now look what we have. We have a right triangle with 2 sides. These are the hypotenuses. These are the legs. We are going to use HL to prove these 2 triangles congruent. Okay? So let's work out how. Well, if these are perpendicular, then we know we have right angles. Angle HIG and angle, so HIG and angle VIT are right angles. And that is by definition of perpendicular lines. So now if those are right angles, then we have right triangles. Triangle HIG and triangle ITV are right triangles. That is by the definition of right triangles. So now we have right triangles established. Sorry about the moving. Okay. So now if I slide this thing up just a little bit, we were already given that these hypotenuses are congruent. So we already have those. So now the fact that I is a midpoint, we can now say that HI, segment HI, is congruent to segment VI because I is a midpoint. Definition of a midpoint. And that is a pair of legs. And we have HL congruence because we have right triangles. So these 2 triangles use their correspondence despite what we wrote in here. Triangle IGH is congruent to triangle ITV, and that is by HL congruence, or HL theorem. So there was an instant where the right triangles did prove congruent by HL. Okay, last problem here. We're going to take a look at this proof now. Okay, so in this proof we are given segment QD is congruent to segment UA, and angle QDA is congruent to angle UAD. And that was given to us. We need to prove 2 triangles congruent. Now, here's a situation where maybe you want to use your 2 colors because notice they overlap, right? QDA is this triangle right here. And I'll use blue. UAD is this triangle right here. UAD. So there's the 2 triangles, okay? So let's first mark what we're given. And I'll use different colors for each one. So QD is in the red. UA is in the blue. Angle QDA is the red, and angle UAD is the blue. So in each triangle we have a side and an angle. We want to prove that triangle QDA is congruent to triangle UAD. Well, what's nice about that is those are the 2 triangles we have highlighted. So there's no need to use 2 congruent sets of triangles, just 1 is fine. So the question is, what else can we use that would make these congruent? Well, they're overlapping triangles, right? They're overlapping. So notice what they share. They both have AD in them. They overlap on segment AD. So we use that in the proof. Segment AD is congruent to segment AD. And that is reflexive property. It's used in both triangles. So we have a pair of side, we have a pair of angles, and another pair of sides. This better be side, angle, side. If I mark it, side, angle, side. There we go. Triangle QDA is congruent to triangle UAD by side, angle, side. So as long as you can see the overlap, you should be very, very fine, very comfortable with these proofs on the quiz, on the test. If I do give you something that has multiple triangles, I will definitely provide you those steps and just have you fill in the reasons. Okay? So hopefully this went well, and you should feel confident going into the test Friday. All right, thanks for watching. We'll see you then.